Hi, in the previous video we talked about how we can express the answer with its absolute uncertainty when we were doing the raw data collection. However, when you are doing a meaningful physics experiment, you probably would not just have your raw data collected and then you move on to plot the graph. There are times where you may need to process the data because some of the data may not be able to measure directly. So for example, if you want to measure density, it is actually not possible. You can only calculate density. So you have to be very careful with the verb here, measure and calculate. What you can do if you really want to study density rho is you can think of the equation m over v, mass over volume, equals to density, because this is the definition. Okay, so that's why I always emphasize the idea of definition is very important, because we start things from definition usually. And since we cannot measure density directly, we can actually measure mass and also volume. So for example, you want to find out how temperature T, like we said in the previous video, or as you all know, temperature probably when you go to a greater temperature, the density would be probably less dense because it expands, right? So maybe this is a experiment you want to study, but then you cannot measure density directly. However, what you can do is you can measure the mass, you can also measure the volume. So that's why in the previous video we talked about how you can evaluate its uncertainty. For example, when you use the electronic balance to measure the mass, maybe there will be fluctuation. So how you deal with the maximum and minimum over 10 seconds. Or when you are measuring the volume using the measuring cylinder with the displacement method, then you would need to do the measurement uncertainty as well, because when you look at the measuring cylinder, you need to think about what is the smallest division, and since it's an analog device, you have to divide it by 2. And after that, you have to think about with mass absolute uncertainty and also the absolute uncertainty from the volume as well, how you can deduce the uncertainty for the density, because they don't simply add up or whatsoever to put together. So that's why here is a video for you called the error propagation, because later on you need to handle something called the processed data after you got the raw data. So this is a very important part for your IA, and basically you cannot do your IA well without it. Before we go deep into propagation of uncertainties, let's just make ourselves clear with some basic definition first. So there are 3 names that you may need to know what it is simply. So like I have been mentioned for many times, absolute uncertainty is simply the number that is behind plus or minus. So let's say here you can see let's say there is a measurement of length that is 28.3 plus or minus 0.4 cm, then 0.4 is the absolute uncertainty. When you talk about fractional uncertainty, obviously you're doing a fraction, so 0.4 divide 28.3. Interestingly, however, fractional uncertainty, fraction should not be the final answer when the exam is asking you for fractional uncertainty. Okay, the first time when I realized this, again my mind was blown, because it's called fractional uncertainty, but I cannot express it as fraction. The reason is that when you do calculate this, yes, you use fraction. So basically absolute divide the so-called mean value or average value, right? The number at the front of plus or minus value. However, since we talk about the significant figures issue, if you express it with fraction, then basically you are leaving the significance figure unclear to the audience. So for example, if I say 10 divide like 10 over 3 as a fraction, then obviously you cannot tell how many sig fig are there. And so that's why in the exam we would not expect you to write, we would not allow you to write the fraction as the final answer as well. And that's why you can see in your textbook here, you also calculate it as 0.0141 in this case. Okay, so that's fractional uncertainty. Percentage uncertainty will simply be the fractional uncertainty times 100%. So very simple stuff. The other thing that we have to make it clear also is the presentation. So the notation, if you follow what we do in physics, then we don't have to do what you do in mathematics. So like when you do solving an equation in mathematics, you just have to say, oh, let x to be blah blah blah, y to be blah blah blah. But then in physics, you know we don't need to do that, right? That's because we have our own system of notation. Like when we see F, we know it is force. When we see P, we know it is power or momentum, although you may say, hey, sometimes it's confusing. Here, let's learn how to write the notation here. So for example, if you have a variable called A, so you can actually change it to other things, like if you're talking about mass, you can change it to M here, okay? So the whole parameter is simply A here, or mass will be M. Then it would equal to A log. So basically the so-called log is 0, you may say. So that is representing the average value or the mean value once again, plus or minus delta A. Okay, so delta A here, or delta M for mass, will be referring to the uncertainty, the absolute uncertainty more precisely. Please don't mix it up with change of. Okay, because when you learn about, maybe in IGCSE, you learn about energy equals to mc delta T in thermal, and delta T was referring to the change of temperature, or even when you talk about acceleration equals to delta V over delta T, right, change of velocity over time. But here, we are really referring to the uncertainty of that particular values only. Alright, and so in that case, that three equation, absolute, fractional, and percentage uncertainty, will turn into this accordingly. So this is a notation that you may use in your exam, and that will help your communication a lot. So please follow that. Alright, so let's start to take a look at the equation that we'll need to use in the data booklet, because at the end of the day, you probably will need to rely on the data booklet. Of course, if you can memorize, remember the equation, I'll be very proud of you. But just in case, alright, somehow, I don't know, maybe you feel nervous in the exam, you somehow just forget, or you want to double confirm again, data booklet will be your friend. So please treat your data booklet well and understand your data booklet better, because it's not perfect somehow. So that's why there's some strategy you need to think about how to remember these things. So maybe you can keep a copy of data booklet, and you can always do some more annotation to remind yourself those imperfections in the data booklet. So let's take a look here. In the error propagation, there are mainly two parts. So very similar to what we did earlier about sig fig and decimal place. Alright, if you remember, sig fig is for multiply and division, and decimal place is for plus or minus. Here is similar, plus or minus whenever you do a propagation. So that is to say, if you remember at the beginning of this video, I talked about the reason why you have to do this is because you have raw data, but now you have to process them. So how do we evaluate the error of the processed data correctly? This is the equation that you need. So if you're doing addition or subtraction, for example, if you are doing, say, perimeter of a certain, say, a rectangle, then you have to add 4 sides, right? So this is an example. If you are doing division, then, for example, mass times acceleration, just say, then you need to do the lower one. Okay, so there are two categories. One is for plus or minus, one is for multiplication and divide. So I guess in this part of video, I will do the first one, and I'll leave multiplication and divide for the next video. So let's take a look of this equation in more details now. So it said if a value is calculated by A plus B. Okay, so here this plus or minus is not referring to uncertainty. Okay, uncertainty is labeled by delta, remember. So let's say you have to have two numbers add together and equal to y, then the uncertainty for y is simply having the absolute uncertainty of that two number add together. Okay, so this is the rule, and it is the same when you do minus as well. So that means if y equal to a minus b, then you also add the absolute uncertainty of a and b together. Alright, because you don't see a negative here. I'll explain to you why later on through some examples. So just remember this first, and if you need to, refer back to the formula here. Alright, so here is an example. It said there's a square with side, I guess, length of a measured to be that much, 12.4 plus or minus 0.1 cm. Find the perimeter of this square, including the uncertainty. So the thing is, whenever you see number with plus or minus something, then when you calculate something, obviously you have to express it as well. I mean, think about this is a physics exam. So if this question is simply asking you, oh, perimeter of a square, so you just do 12.4 times 4, then I guess you're too naive, right? This is more like junior maths, right? We are not testing you this. Why do we have to test you this? So we are testing you how to propagate the error instead. So what we can do here is, let me show you as a demonstration. In fact, this is meaningful, but then this is the mean value. Okay, so what I would do is I'll put p log here, and this is the value of p log, and that is simply like how you normally calculate. So I'll do 12.4 times 4 because there are 4 sides, or you can just simply add them up together, and that will be 49.6 cm. Okay, because for the final answer, we want to express perimeter p with p log plus or minus delta p. So we already find p log already, and we just have to find delta p. Okay, so since p is, well, you can actually write the equation at the beginning, which I skip because it's simply too easy. It will be a plus a plus a plus a here, all right, or simply 4a. And therefore, for delta p, according to the rule that we learned, since p is composed of these 4a add together, then the uncertainty of p will be delta a plus delta a plus delta a plus delta a. Alright, so I mean, if you imagine these are not all of them but a is a, b, c, and d, then this is the same. Delta a, delta b, delta c, delta d is all the same. Okay, so this is just a simple, really simple example. And so since delta a, this is delta a by the way, alright, 0.1, so 0.1, okay, I'm too lazy, so I'll just write times 4, so 0.4 it is. Okay, so that's why we have delta p as well right now. So it's like cooking. Now we prepare everything and just put them back to here. 49.6 plus or minus 0.4. Okay, and let's not forget to put down a unit. And when you do this, you have to put a bracket unless you want to write cm twice. One more thing that you should do is that you should check whether or not the decimal place of your uncertainty match with the mean value. That's again something to do with whether or not the uncertainty would be meaningful or not. Okay, so this is a rule of thumb that you should be following as well. Okay, so now I'll explain to you why do we have to follow that particular equation, because in physics it's always good to know why. Why do we have such an equation, right? So let me try to explain to you. Think about this. When you have a square, let me draw a square with my best of ability. Okay, this is my best. And each of them is with a side A. Okay, so what you're trying to find at the end is you want to try to find the range of perimeter actually. Okay, because in IB physics, we are not just caring about a particular number, but we care even more on how confident, once again, how confident you are with your answer. Okay, so from what range to what range you are 100% sure that it is possible here. So That's why if you think about the actual perimeter of this square, it would not just be 49.6. Think about the worst case. So the worst case could be what? It could be having the A, each of these A to be the largest. So that is to say, this is 12.5, this is 12.5, and same for the others. And if you think about that, that is to say the so-called maximum perimeter will be 12.5 times 4, which should equal to, I think this, yeah, will be exactly 50.0, right? cm, of course. And the other worst case, obviously, will be the minimum, right? And if you think about the minimum of P, then you have to think about the minimum of A, obviously, with such an equation. So in this case, then it will be 12.3, 12.3, and same for the other two, like for every A here. So in this case, you will generate the shortest or smallest amount of perimeter, and that is to say the perimeter will be 12.3 times 4, and that is 49.2 cm. Alright, so I hope you already get the idea, because if you look at the so-called maximum and minimum value, this is basically the range of the one that we find out by using the equation. Can you see that? Right, if you minus 0.4 here, then you get the lower bound that we calculate, which is 49.2. If you do the higher bound, that is the maximum, you will get 50.0. So that's why we rely on that equation. Okay, for the next question is about minus. So in fact, minus is very similar to plus. So I will want you to try yourself. So please pause the video now, try it, and we'll discuss the answer.
2,000 years later.
Let me show you how I would do it, and please also pay attention to my presentation as well to use a good notation and a good logical way of flow as well. So first of all, since we want to find the percentage uncertainty of Q, I guess we have to find how Q is expressed first. So I would say Q log plus or minus delta Q. This is something that we want to express, and then eventually percentage uncertainty we can use this symbol to represent, would equal to delta Q over Q log times 100%. So for Q log, because this equation is already written, so I guess it's fine, we can just go ahead with A log minus B log. Alright, I will write down the symbol instead of directly going to 500 something and 500 something, because this way I can show a better understanding. And in case if you make a mistake in the exam paper, you may still have a chance to get 1 mark here. So what you do for A log apparently is get this number in, and then B log will be this one. And so the answer would actually be 1.4, I think, right? I don't need calculator. There's no unit, so I can just leave it. As for delta Q, okay, remember for no matter plus or minus, you always just add the absolute uncertainty together. So what you do here is simply delta A plus delta B. Again, I'll write the general formula first, and you will then have the substitution 0.3 plus 0.5, that is 0.8. So that is to say Q would be able to express as 1.4 plus or minus 0.8. And so for the uncertainty, okay, I should have a better space management. That would be 0.8 over 1.4 times 100%. And by using your calculator, you'll be able to find the answer that is around 57.1%. And I do think we can only express with 1 sig fig with such a question, but then I think that's the only choice. So I would do 60% then, right, which is a huge percentage error for sure. And once again, I will hope to go through a more metacognitive idea with why we have to follow the formula in negative. Like even when you do subtraction, why do we still add the absolute uncertainty together? So it's very easy to think. So let's just think about the worst case. When you have Q equals to A minus B, what could the worst case be? So that is to say, what would be the maximum of Q and minimum of Q. So for maximum of Q, what do? You do maximum of A minus minimum of B, right? Because this is how you can make Q to be biggest. And so in this case, you have, I'll just substitute directly, okay? You have 539.0, right? Because it's plus 0.53, and then this one is minus 0.5, so that will be 576.8, right? And that should equal, I think it's very obvious, 2.2. Okay, and 2.2, if you look at this value and our final answer, this one is the upper bound, is 1.4 plus 0.8. Yeah, it's 2.2. Similarly, for the minimum of Q, you're doing it the same way. So I really hope you can go through this. And this will be minimum A, because you want to make Q the smallest, minus the maximum B, and that will be, sorry for the space here, but then this should be 538.4 minus 5, again the biggest B, so plus 0.5, 538, no, sorry, it's 537.8. Okay, so if you minus these two numbers, then you simply get 0.6, and 0.6 is really the minimum of these as well. So I hope you can now trust the equation that we introduced to you, and you just use it for the other questions whenever you do addition and subtraction.